Good evening. This is FamilyMath510b.
Alright.
So, do you remember this project? I didn't get a chance to talk to you this morning about it. Do you remember the project when we made spheres from the Kelsey Edwards video?
Yep.
And they were different ways of measuring distance. So, this sphere here, what we would probably normally think of as a ball, is the normal way of measuring distance. So, like the Pythagorean theorem, essentially.
Yeah.
And this way was the L1 metric was what she called the taxicab metric. Remember that?
Yeah.
Okay. So last night I had kind of just a crazy idea before going to bed of trying to do the same thing for the torus. So this would be the taxicab torus comparison to this. As you know, this fun torus idea turned into a printing nightmare when they didn't quite print, and then they melted into the tank. So I learned how to clean the 3D printing tank, but I did manage to get them all printed. So this was the 0.75 metric sphere torus, the L1 metric sphere torus, L1.5, and the 1.5 torus, L2. I don't remember if this was L2.5 or L3, but this is let's call it L3 sphere in torus, and then this was the I think L4. What do you think the L4 torus would look like?
More squarish than this.
Even more square.
Yeah.
So what are some things you notice about these shapes? Since I haven't talked to you about these shapes.
Well, they follow the same sort of progression.
Okay. What do you mean by that?
Like, on these two shapes, they both have like these weird incurves.
Okay.
And then here you've got straight edges.
All right.
Here you're sort of progressing. It's sort of a mid-stage between this and the sphere.
Mm-hmm.
You can still see the corners, but the edges are bulgy.
Yeah, actually, does this have some straight lines? It does. Does this? Can you tell?
No, they're all sort of curved.
You think they're all curved? I'm not sure. I think they probably. Well, look at it more carefully. Actually, I think there are some straight lines on there. You can touch them.
Yeah, maybe.
Yeah, I think there are some straight lines. This is sort of like this. I think you called this the balloon octahedron. But anyway, okay.
And then, so here's our standard torus/sphere.
That's an incredible coincidence. That was not done by design, but good noticing. It almost fits perfectly.
And then here's sort of our mid-stage between cube and sphere.
Yeah.
And we sort of see that.
That actually makes me wonder how the other ones fit in together, because they should all actually be the same size. That one actually passes through.
Yeah, so does this one.
Doesn't it? And it's interesting the sphere doesn't pass through.
It doesn't.
Huh.
That one.
Cool. All right. Tell me something else. Tell me something else you see that's similar in the progression.
I mean, they're getting bigger.
Okay.
Like this is the smallest amount of resin used to make this.
Mm-hmm.
More, and then.
Yeah, and that's actually a feature of them, because you can see the same thing happens with the spheres. So these are all the same size spheres.
It's all like a radius of 1 away from the
Right,
point.
it's all a radius of 1, and they're all the same scale. And so you can see how they grow. And it's the same thing here. These were, I think the outside radius was 0.75, and the inside radius was 0.25, I think. I think it was 3 times here to there. All right. So what do you think is the most interesting shape of these?
Well, I mean, like this one's pretty interesting.
Okay, so when you actually get the P bigger than 2.
And I think it's more sort of squarish around the outside.
All right. Do you think that this is the most interesting sphere too?
Yeah, it's like, I mean, this and this both sort of the mid stages between something that's recognizable.
Okay. I want to ask you the same question I asked your brother. Do you believe this is a sphere? The shape? Do you believe that?
If you're defining distance a certain way, that could be a sphere. But in our distance, spheres you normally think of as being able to roll like this.
Uh-huh.
But this can't roll. Not that well.
Not that well. In fact, that's a 8-sided dice. Yeah. So it's interesting, but we don't usually think of distance differently than the Pythagorean theorem or
It's two points A to B.
Yeah, that normal way of measuring distance. We think of that as a standard way of measuring distance, and we don't usually think of distance as being just a definition. But if we change the definition of distance, these are what spheres look like, these are what toruses look like. It's pretty fun. What do you think about this? Do you think this is an interesting math project?
Yeah.
Me too. Me too. All right. Good job, hon.